Hey folks, welcome back to the Metal Mill 52 workshop. My name is Bill, this is my shop, and we're working on an LBSC TICH locomotive. Let me do a little aerial shot over it, take advantage of some of the natural light. It's Sunday, Mother's Day. Happy Mother's Day to all the moms out there. I just got to talk to mine this morning and had a wonderful conversation. In this episode, we're going to cover making the exhaust assembly here. It sits in the chassis like this, down here, down low, and it will exhaust the spent steam gases from the cylinders. So stay tuned and hope you enjoy this episode. If you have any questions, please ask. I try to go through it pretty carefully, and please give me a thumbs up. It's always encouraging to see the thumbs up from people, and I appreciate that. Hope you all have a great week. Thanks, everybody. See you soon. There's a little LBSC TICH chassis sitting all by itself over on the big workbench. And I put it there so I'll have open spaces here to work on the intake and exhaust pipes in the book, about page 113, 114. I've read through these things and made notes, and one of the things, LBSC is fun to read because he's chock full of anecdotes, but one thing I find helpful for me is to just take and write down sort of a step-by-step set of directions. So I've also taken the time to go through and list the taps and dies that I'm going to need. A 1/4 by 40 and 5/16 40 figure prominently, or 3/16 40. So I keep these, I've got in the little Altoids boxes that I keep some of the ones that are not part of the bigger set together. So there's my 5/16 40, my 3/16 40s, and I do the 1/4 by 40s I have in a big set, so I just made a note of what set that they're in. Also, here's the little lubricator that I bought off of eBay. We'll be working on that again soon, and I've laid out some of the materials, some of the 3/32 inch tubing that'll be for the oil supply. And right here I've got the 5/16 inch thick copper tube that we'll be needing, and underneath here is some of the 1/4 inch thick walled copper that will be part of this project. Also here, 1/4 inch is drill rod that I'll be using to make a, there it is, what I always mark is water hardening drill rod. It's impossible to tell the difference between this stuff. I've got 1/4 inch and 3/16, so when I'm using a piece and I'm done with it, I'll save it and I'll put a tag on this so I can easily say, oh yeah, that's what that is, and you don't end up trying to use regular steel for drill rod. And lastly I found some 5/16 inch hex brass and 7/16 inch hex brass. This will be the exhaust cone. This will be the material that for some of the nuts, the lock nuts and so forth on the exhaust pieces. So there we have the basic materials laid out for this part of the project, and very importantly is the casting. So I bought this casting, did not come with the original set, but it's easy to find. I think Blackwell's had this, I'm not for sure, one of the British suppliers, and I bought it when I got the other casting pieces. So it was relatively inexpensive and easy to get. So the first thing we'll work on is the exhaust, and that's the smaller of the T, and it's pretty straightforward. Cutting it, drilling and tapping, and then getting rid of this little tail piece here because it's just a chucking piece. But the first thing I'll need to do is put the thing in a vise before I cut it apart. I'll put it in a vise and file off the casting flash. That'll be easy to do. Then I'll cut it in half and I'll start machining the exhaust part first, and then the steam supply one we'll do that second. So kind of break this up. Probably this weekend, this video will just be all about the exhaust pipe. But can't wait to get started on this. It's just one more step to get it closer to running on air. Here's a cleaned up casting. I used a file for most of it, and then I just did hit it with the belt sander there quickly to clean up some of the edges. And I think I said like Blackwell's or something. What I mean, I believe I got this part from Reeves 2000, now that I think about it. And I think I was referring to Black Gates Engineering, that when I said Blackwell's. Black Gates is the company that Keith Appleton buys a lot of his stuff from, and they may have these castings, but I'm pretty sure I got this from Reeves 2000. So sorry about that. Yesterday I made the little threaded nuts, the lock nuts, and the ones that will be silver soldered on. So I've got them. There's the threaded ones. That'll be the lock nuts for the exhaust passages. And now I'm getting ready to make the cone taper, that cone taper reamer, whatever you want to call it, that they talk about in the book for the exhaust stack. So what I've done, pardon me the pan, cut off a piece of 1/4 inch drill rod, got it in the 5C chuck. I just faced off the end and I colored the whole thing with blue. And I've set it at, I think this is 3 degrees, something like that so far. What I'm going to do is just play with the taper, since I know where my center point's going to be and the end point. I can just adjust the angle, the steepness of the angle to, it should be pretty obvious to give me the cone shape that I need. So I'll do that and I'll bring you back and show you what I come up with. There's my taper. It's about 18 degrees. I tried 20, but that was a little too shallow. So I ended up with about an 18 degree, and I think that gives me a nice cone point with about 3/8 of an inch of travel there. So I'm going to file it smooth and take it. The nice thing about the 5C, I can take it over to the mill, put it in a collet block, and mill off the top half. There we go, after just touching it with a file and then some 400 grit sandpaper. It's looking nice and smooth and look like a beginning of a cutting tool. Here's our cone blank in the 5C collet chuck. And I marked basically where the end of the 3/8 inch goes. I've got an end mill here, so just thought I'd take a quick video before I stick it in the mill. It's going to be harder to see, but I'll put it in and easily just use the DRO to touch off the top and go halfway deep. So 1/8 of an inch and 3/8 of an inch in, and we'll be good to go. Okay, there we go with the top half of it milled away. I hope you can see that. It's funny, it kind of looks like an X-Acto knife from this angle, but we'll go ahead and get it, take it out and get it ready and heat treat it. And here we have the threaded portion. I put the 1/4 inch copper tube in. I threaded the 3/16 inch portion first, since I just wanted to try it. I did it completely by hand using the tailstock die holder, and it came out well. I used the tap paste lubricant, and just as LBSC described, or very similar to it, rotating the thing by hand and going back and forth to cut the chips. Worked out good. Now I just need to cut it off at 1 3/8, reverse it, and thread the longer portion. After I've threaded the little pieces of copper pipe, it occurred to me that if I had checked it, it's been a long time ago, the threading on the cylinders for the exhaust, and so that's why I put this in here to test. And sure enough, they are 1/4 by 40. And let me do a little sneak preview here for you. Here's a little casting tee that it's unmachined as yet, but it'll sit right there in the middle, in the center. And happily, yes, these were 1/4 by 40 machined in the cylinders, so I'm pretty happy about that. Take that all the way out and you can see. So it threads in there nicely. I need to clean up and deburr these ends before I cut myself. And while I'm test fitting things and pointing out about copper tube, these are the exhaust pieces are 1/4 inch copper. The steam intake are supposed to be 3/16 inch copper, and luckily I have this huge coil of 3/16 inch copper, so I'm going to try to straighten this out. You know, the pieces only have to be 1 3/8 inches long, so it shouldn't be that hard to get a straight piece. So I've carefully hand unwound a section of it, and I'm going to cut it off with my little baby cutoff thing, and then try to straighten it out with this V-block here. Here's a little tip I learned from Fred. I'm now trying to thread the 3/4 inch portion of one of the exhaust pipes. So I put it in, I cleaned it up with the cutoff wheel, and then I just gently filed it and put a rounded edge so it would be easier to start. And because this is a big flimsy piece, only put out about a 1/2 inch of it at first, and I've threaded about 3/8 of an inch of it. Now I'll loosen the 5C collet up again, slide it out some more, and then do another section of it. Not even sure I'm going to try to do the whole 3/4 at this juncture, but maybe pull it out another 1/8 of an inch or so and do a little bit more, and then restart it and kind of lather, rinse, repeat, if you understand. That way, least likelihood of bending off the copper tube in half. Okay, it was painstaking. I did it in smaller increments, but hopefully you can see there's the 3/4 inch threaded section. Came out good. Now I get to do the other side. Well, I had the setup here for the little pipes. I thought I'd do the 3/16 inch by 40 ones, and this one was, even though I straightened it out and I only had this much sticking out, it was way too soft to thread it this way. So I may have to try to pull it and work harden it a little bit, but before I try that, I thought I would cut off a section and just try a really small area at a time. Let's see if that'll work. Well, last night I made a perfectly good 3/16 inch copper steam supply tube, although this portion is not a work of art. It did thread into the cylinders okay, and this part came out really good. And believe it or not, the back side of the one that's in the lathe now is perfect. It's like a whole 3/4 inch length like this. And I thought, well, all I've got to do is put this little 3/16 inch thread on last night, and I started to do that, and I caught with the tailstock die holder, I caught the tubing at an odd angle and kind of started to squish it. Well, luckily, and I was turning the thing like this by hand, so luckily I did back off before I ruined it completely, and I just let it be. But what I'm thinking of tonight is maybe try to massage the copper back into a round place, take it out and put an 1/8 inch, maybe if I can get it halfway around, I could put in like an 1/8 inch piece of bar, rod rather, super glue it in there, and it'd be stiff enough. So I'm going to try that now. I'll bring you back and let you know. If not, I do have plenty of the straightened 3/16 inch copper left, and I could always try to make another one. Alright, that seemed to work out pretty nicely. I did get the end of it a little bit rounder just by using some pliers, and then I drilled it out just to make sure I had it round inside. And I don't know why it's not focusing. And then I used crazy glue to glue this drill bit inside, and it made it nice and firm. So I wish I would have done that from the very beginning, use the crazy glue. I wouldn't have to worry about the darn things collapsing. So now I'll just put this in a vise, protect the drill bit itself, and then heat it up with a heat gun and pull this off with a pair of pliers. Well, the rescue attempt, you can see side by side what I meant by this one here, which is the one I screwed up this end. Much prettier overall job, especially on the long end. But that trick of putting it, crazy gluing in a drill bit to give it stiffness worked perfectly, and I was able to rescue it just fine. And in fact, I went ahead and drilled out both of them to make sure I used a number drill that's 120 thou, but to make sure we had clear passages for each of them. And while I was at it here tonight on the lathe, I've got the 5/16 inch brass. I made a couple of 3/16 inch smooth bore that can be soldered on, and then I made 3 of the threaded versions of 3/16 40 threaded rods. So I'll be all set just like with this one. So I think tomorrow night what I'll do is work on the castings, and both drilling and tapping them. Pretty straightforward for the exhaust one, and not too much more complicated for the steam intake one. but I do need to make an oil fitting for the bottom. About to do the last step on the blast nozzle here. Simply followed the directions in the book. Cut a 1/2-inch piece of 7/16" brass and drilled the hole through it and drilled and tapped it for 5/16 40. Just finished that, and now I've chucked up the custom made taper cone to give it the cool blast nozzle sound, and I'm getting ready to do that, and then we'll take it out and take a look at it. Thought I'd take a quick shot of this. This is the exhaust tee, and now comes the fun part after messing about with all of the copper tubing and the blast pipe and all that stuff. I'm finally getting ready to machine this, and I thought it was cool how they had stamped on here Titch. So I'm getting ready to face off this side and center drill and drill through, tap 1/4 x 40, and then put it in, use the chucking piece here, kind of repeat the process except for the 5/16 40 on the top. Pretty simple. And then this is supposed to be removed. I guess I will, I don't know. We'll see. But pretty simple process to finish the base of the exhaust pipe. I'm not going to film all this stuff. I already have plenty of video, just thought I'd show it, especially with the little cool maker's stamp mark there. Okay, this was fun. There is something about it, if you haven't done it, machining castings, even something simple like this, it just really is fun. And it's kind of cool when they have included the little chucking pieces for you. So I did it just like LBSC talked about in the book. I did one side and then the other. I drilled all the way through on the first pass, but my tap is not long enough, so I flipped it around. Luckily, that's why I cleaned up one side and then the other, so I would have a good center register, if you will. And then I just cleaned up the outside of this one, drilled it and tapped it for the 5/16 40 for the actual exhaust pipe. And now the only thing left to do, I'd love to leave the chucking piece on for extra weight, but it occurs to me that could be in the way of other things down below the bottom of the locomotive, most notably the oil line that comes from the oil pump to the steam pipes. So I think while I'm got it here, I'll just take a hacksaw and hacksaw it off clean, and then I can use the belt sander to kind of round it and smooth it. Okay, here is the completed exhaust assembly, at least dry assembled. I haven't silver soldered the little nuts on yet, but this is, let me just show you where it'll go. I was just doing a little test fit, and sure enough it test fits fine. Here, sorry, I'm trying to do is to get it into that hole on the left hand side. So anyway, there you can see it'll be good, and the size is just right, and I'll be able to use these nuts here, the ones that I silver solder on, to tighten the tubes into place, the exhaust tubes into place, and then it'll sit like this. So it's kind of late on Saturday night. I'm gonna silver solder those tomorrow, and we will wrap up this video then. I'll show you the brief closing sometime tomorrow. Couldn't resist one more shot of the completed assembly. There it is with the ends extended out and the lock nuts snugged up a little bit. Alright, after test fitting it dry, I took the completed assembly apart, set up my little rig, and I've silver soldered the little nuts in place. Look pretty scraggly now, but they're cooling. I literally just finished soldering them a minute ago, so we'll let them cool a little bit, and then we'll dunk them and pickle them and polish them up and show you the finished product. Okay, here's the finished exhaust assembly. I kind of used way too much silver solder on there, but I'm quite certain that those little nuts are not going to go anywhere, and we already know that it fits inside the chassis, so I'm going to let it sit right here until we get ready to put the whole thing together. And like I said, thanks for watching, everybody. Hope it's been interesting for you. Please give me a thumbs up, ask a question if you like, and I'll do my best to answer. Stay tuned for the next episode. See you soon.